In this video, we're going to be looking at factoring polynomials in quadratic form. So polynomials in quadratic form, when it can be written as au squared plus bu plus c, where u is an algebraic expression. These polynomials can be factored using similar techniques we have learned when factoring quadratics. So for instance, u in this case could be x squared. And so I would have a x squared plus bx squared plus c. Or in other words, ax to the fourth plus bx squared plus c. But we would be able to still factor it as we would with a normal quadratic. So let's look at some examples. I want to factor these completely. So I have x to the fourth plus 9x squared plus 20. I can rewrite this to be in quadratic form if I let u equal x squared. So instead of x to the fourth, I can rewrite this as x squared plus 9x squared plus 20. And now I'm going to factor this just like I would with a normal quadratic. So I'm looking for two numbers that multiply to 20 and then add to equal 9. 1 and 20, 2 and 10, 4 and 5. I see 4 and 5 add to 9. So this can be factored as x squared plus 4 x squared plus 5. So it looks just like our quadratic, but now instead of x being our first term, it's just going to be x squared, which we see in that first term here. Okay, let's look at another example. Here I have 16x to the fourth minus 81. So I have this subtraction. It almost looks like a difference of squares, but I have this raised to the fourth power. So I can instead rewrite this so that it does look like a quadratic. So I'm going to see what squared gets me 16x to the fourth. Well, 4 squared gets me 16. X squared gets me x to the fourth. And then this is the same thing as 9 squared. And now I can go ahead and use difference of squares to factor this. So my a is 4x squared, my b is 9, and so I have 4x squared plus 9 and 4x squared minus 9. Really tempting to say that we're done right here. However, I actually have another difference of squares, and that is with this second binomial. That second binomial, I can rewrite that as being 2x quantity squared minus 3 squared. And so that means I have 4x squared plus 9 times 2x plus 3 times 2x minus 3. Okay, let's look at one more. Here I have 3x to the 8th plus 15x to the 5th plus 18x squared. Here I see I do have a GCF. First I see that 3 can go into all these and x squared. So I have 3x squared that I'm going to factor out. And when I factor that out, I'm left with x to the 6th plus 5x cubed plus 6. So I have x to the 6th plus 5x cubed plus 6. And I can actually rewrite this so it looks like it's in quadratic form. And you can normally tell if it's in quadratic form when you have your first exponent is divided by half to get your next one, and then you have no variable. So like 6 divided by 2 is 3, and then no variable. That means you can rewrite this in quadratic form. So to do that, I can allow u to equal x cubed, so whatever that second term has. And so I can rewrite this as x cubed squared plus 5x cubed plus 6. So I'm looking for two numbers that multiply to 6, but then add to 5. And I say it's going to be 2 and 3. And so this is going to equal to 3x squared times x cubed plus 2 times x cubed plus 3.